Welcome back. So we're going to be examining what happens to the function as x approaches x naught. Right? So what value does the function approach as x approaches x naught? So we're going to look from the left. Right? So from the left, so we're coming from the left and we're getting closer and closer to x naught. Right? What value is our function approaching? Well, f of x appears to be approaching 2 as x approaches x naught. So the limit of f of x as x approaches x naught from the left-hand side is equal to 2. How about from the right-hand side? Right, so we're going to just kind of follow our function along until we get as close as we can to x naught. From the right, f of x approaches, well, look at our graph here, 1, 2, 3, 4, as x approaches x naught. So the limit of f of x as x approaches x naught from the right is equal to 4. So does our limit exist? Well, let's look at our left and our right hand limits. The left hand limit is 2 and the right hand limit is 4. Right? So the limit of f of x as x approaches x naught does not exist because the limit of f of x as x approaches x naught from the left does not equal the limit of f of x as x approaches x naught from the right. Both the one-hand limits exist. The left-hand limit exists, it's 2. The right-hand limit exists, it's 4. But since they're not the same value, the limit, the two-sided limit, does not exist. Both of our one-sided limits exist at 4, but the two-sided limit does not exist. Okay? So two-sided limit requires us to look for both sides. Let's look at this one. The limit as x approaches 3. Right, so we're going to look from the left-hand side and the right-hand side. I'm going to start with the right-hand side. Right? And I don't have the values of the function in here. All right. So, and I guess I wasn't sure if I was going to leave them as, you know what I'll do? I will get a decimal equivalent because, can I bring up a calculator? Yes. Many things I can do in my head. This is not one of them. I have no idea if you see the calculator, but that's okay even if you don't see the calculator. Oops, there it goes, because I can still write the values. Although I have to remember not to touch the screen or the calculator disappears. All right, so if I plug in 3.1, I'm going to have the square root of 3.1 minus 3. All right, so that's going to be the square root of 0.1. And square root. All right, so I don't know if you see that value. I'll find out when I look at this video whether or not it shows the calculator as well or just the smartboard. All right, but that value is 0.3162. We'll take it to that many decimals. All right, let's plug in 3.2. All right, so that's going to be 3.2 minus 3. Right, that's going to be 0.2. Right, so if I take the square root of 0.2, that's 0.4471 or 21. All right, what happens? And I'll write the values down in a moment, just in case you can't see the calculator. All right, and what happens if I plug in 3.3? All right, so that'd be 3.3 minus 3, it's going to be 0.3, right? So 0.3, square root of 0.3 is 0.54772. What happens if I plug in 3? That's just going to be 0, right? Square root of 0. What happens if we plug in 2.9 and 2.8? Let me write these values in, and then we'll look at what happens if we plug in those values. right? So we've got 0, 0 here, right? And then we have 0.3162, and then we had 0.44721 and 0.54772. Right? So the limit of square root of x minus 3 as x approaches 3 from the left, that one appears to be 0. We're getting smaller and smaller, and the value of the function actually exists at 3. Right? So that one appears to be 0. How about, oh, I'm sorry, I put left. I'm sorry, the right. The limit of the square root of x minus 3 as x approaches 3 from the right. Right? We're approaching from the right. These are values that are greater. This is our right-hand limit. Let's look at our left-hand limit. Right? Let me get that calculator again and see what happens if I were to plug in values from the left-hand side. Right? So if I have 2.9 minus 3, I got negative 0.1. What happens if I take that square root? My calculator says not a number. So, does not exist. What happens if I plug in 2.8? I'm going to have the exact same problem. I'm going to be taking the square root of a negative number. Does not exist. Matter of fact, even if I were to get closer, anything on the left-hand side, I'm going to get not a number or domain error, right? The smallest number I can plug in is a 3, because after that, I'm taking the square root of a negative number, which does not exist. That's an imaginary number. And we're only dealing with real numbers. So the limit of the square root of x minus 3 as x approaches 3 from the negative side does not exist. Does the limit of the square root of x minus 3 as x approaches 3 exist? Well, let's take a look. From the right-hand side it exists, but from the left-hand side it doesn't exist. And if we go back to our definition in the previous podcast, if either one-sided limit does not exist, then the two-sided limit does not exist. So this is a tricky one. If I had asked you, what's the limit? You might tell me, oh, well, the limit's 0 as x approaches 3. But in this case, this limit does not exist because the limit doesn't exist from the left-hand side. Very tricky function, very tricky problem when the function doesn't exist for values to the left. When that usually in a problem like this, you might just be asked for the right-hand limit. So you'll see problems in homework, in some of your homeworks, where your function doesn't exist on the left-hand side, and you're only asked for the limit from the right-hand side. Well, the reason I asked you for the limit from the right-hand side is that since the limit from the left-hand side doesn't exist, the whole limit doesn't exist. So here's a really tricky example that I wanted to show you so that if you see that later on, right, you won't be stumped. Right? You'll know that in actuality that limit doesn't exist because the function doesn't exist from the left-hand side. So you have to be careful that your function's existing from the left and right-hand side. Otherwise, you can only take a one-sided limit. Right? So if your function doesn't exist on one side of your point, then you can only take a one-sided limit. How about this one? Right? So we're going to consider the functions. So now we're going to look at a function as x approaches positive and negative infinity. Right? What's happening there? Right? Right? So we're not saying that that we're not approaching real numbers. We're approaching real numbers. We're just approaching numbers that are bigger, smaller and smaller in the first case, and bigger in the second case. Right? And so I have so that we could do both limits here. By the way, if you're finding the limit of a function and it's as x approaches negative infinity or as x approaches infinity, can you be less than negative infinity? No. Can you be more than infinity? No. So these kinds of limits, so when we have limits, as x approaches positive or negative infinity are always one-sided limits. And these are always one-sided limits. So we don't write in that. So in this case, this one here would be a right-hand limit, right? Because there's nothing smaller than negative infinity. And this one would be a left-hand limit because there's nothing greater than infinity. So we're looking at values that are greater than in the case of the negative infinity and less than in the case of infinity. But we don't bother to write in, you'll never write in a plus or a negative here. It's understood that that has to be a one-sided limit, all right? So just so you know, those are always one-sided limits. All right, so we're going to be looking in one direction here, and then we'll look in the other direction. Let's find the limit as x approaches negative infinity. Right? All right, so I started off with a very small value, 0. Right? So our function here is 1 over x. So we're finding the limit. Let's write that function in. The limit of 1 over x as x approaches negative infinity. Oops. Not negative 8. Negative infinity. Of course, if I plug in 0, get an error message, right? That's not real. That does not exist. Right? I could put an error. Maybe I'll just put in does not exist. Right? 1 divided by 0, that's nothing, right? That's impossible. If I plug in a negative 10, I'll have 1 over negative 10. This would be 1 over negative 100, 1 over negative 1,000, 1 over negative 10,000, 1 over negative 100,000. Before we figure out what the limit, let's look at the values in the table for the limit of 1 divided by x as x approaches infinity. Right? So larger and larger numbers. All right, so I plug in 10, I have 1/10. If I plug in 100, I have 1 over 100, 1 over 1,000, 1 over 10,000, 1 over 100,000. All right? So as we look to the left here, are we approaching some value? If you divide 1 by larger, well in this case, in larger and larger numbers in the negative direction, but you can even ignore the negative. If I'm dividing 1 by larger and larger numbers, as I look to the left and as I look to the right here, what's going to happen to our function? So if you're not sure, go ahead and plug that into a calculator, all right? So for instance, let me see if I can drag that calculator again. That would be nice if it actually taped the calculator. I'm not really sure that it does. I don't know. Well, maybe it does. Maybe it types everything on the screen. I'm blocked by a screen recording box that I know you don't see. All right, so let's take 1 and divide that by 100,000. That's pretty small. What if I put in a larger number? Well, eventually, my calculator is going to start rounding, right? And that number, what if I do 1,000,000? 1 divided by 0, 1 more 0, right? 3, and yes. It's even smaller, right? So whether I'm coming from the left or from the right, we're going to keep getting smaller and smaller values. So the limit as limit of 1 over x as x approaches negative infinity is going to be equal to 0. And the limit of 1 over x as x approaches infinity is going to be equal to 0. Right? So here we can look at the limit as x approaches an increasingly a number that's getting increasingly smaller or increasingly larger. And in both cases, it happens to be 0. Right? Even though these are negative, right, they're getting less and less negative, right? They're getting smaller and smaller. And let's take a look at what this function looks like to confirm what we found from our table. Right, so y equals 1 divided by x. That would have a vertical asymptote here at 0, right? We can't plug in 0. You probably know what the horizontal asymptote is. This class you're going to find out why we have horizontal asymptotes. All right, so if I were to plug in some values, right, so here this would be 1, and this would be 1/2. And as x was getting larger and larger, we saw from our graph, right, our table, that y is getting smaller and smaller. Same thing happens over here. If I plug in -1, I get -1. If I plug in 2, I get -1/2. And you can't cross that asymptote. But again, we're going to get closer and closer to 0, right? Because as we plug in larger negative numbers, it's going to, while it's still on the negative side, those values are getting smaller and smaller. So our limit of 1 over x as x approaches negative infinity is 0. And the limit of 1 divided by x as x approaches infinity is also 0. And we can see that graphically. I think that might be my, one more limit from the right and the left hand side. And then we're going to look at some piecewise functions. So we want to find the limit of the following using a table of values. So we have the limit of 1 divided by 2x as x approaches 0. All right, well, let's take a look here. All right, so we've got values from the left-hand side. All right, we have -4, -3, -2, -1. We have -1/8, -1/6, -1/4, -1/2. 0, of course, we'd have 1 over 0. That does not exist. If we plug in 1, we get 1/2. 2, we get 1/4. 3, we get 1/6. 4, we get 1/8. Yeah, these values are not very close to 0, are they? 1 and -1. So we got 1/2 and -1/2. Do we have a limit here? Well, let's look a little bit closer, and let's look between -1 and 1. So now I've plugged in values that are even closer to 0, right? And let's see what we get. Right? So we know that when we had -1, we had 1/2. We had -0.1, we have -5. We have, -1/100th, we have -50. So look what's happening to the values. As we get even closer to 0, our values are getting, on the positive side, they're getting larger. On the negative side, they're getting larger too, but in the negative direction. Right? So as x approaches 0, are we approaching the same value? Well, we can see pretty clearly here, -500 and 500, that's not the same value, right? So our limit as x approaches 0 does not exist. Now, is it because the right hand and the left hand limits aren't the same? Well, let's take a look at this graph. All right, so we have y equals 1 over 2x. Looks a lot like 1 over x, right? We have this asymptote right here, that vertical asymptote, right? And we can plug in some values right from our graph, right? Or from our table, right? So there's some values from the table, right? So this was 1/2. This was 1/4. Right? So as these values were getting further and further away from 0, notice they were getting smaller and smaller, right? 1/8, that's smaller than 1/6. If I were to plug in -5, right, then I'd have -1/10. So here, oops, I'm on the wrong side. Here I'm on the wrong side. right? So we were on the negative side. So here I can't cross this line. But as these values are getting closer to negative infinity, right? The value of the function is getting closer to 0. Right? But look what happens right here as we're getting closer to 0. Right? Well, our function is growing without bounds in the negative direction. On the other side, these are the values from the table, right? Again, as x goes to infinity, right, these values are getting smaller. But as x goes to 0, as x approaches 0, these are going to keep getting larger and larger as that gets closer and closer to the asymptote. So here, the limit of 1 divided by 2x as x approaches 0 does not exist, and neither do the left and the right-hand limits, right? We're not approaching some value, we're just increasing and decreasing without bounds. Right? So I think this is where I want to stop. Actually, this will be my last page. So if we say the limit is infinity or negative infinity, the limit is still non-existent, right? So from the left-hand side, over here, the limit of 1 divided by 2x as x approaches 0 from the left, that was negative infinity. The limit of 1 divided by 2x as x approaches 0 from the right was infinity, right? But the negative infinity and infinity are not values, right? We're not approaching a finite value. Right? So if our limit is infinity or negative infinity, the limit is still non-existent. Think of infinity as and negative infinity as special cases of does not exist that we do write when appropriate. They indicate why the limit doesn't exist. Right? As we approach 0 from the negative side, right, we decrease without bounds. As we approach 0 from the positive side, from the right-hand side, we increase without bounds. That's why the limit doesn't exist. Right? And our two-sided limit doesn't exist because neither of the one-sided limits exist. Right? So our limit of f of x as x approaches a exists if the limit is a real number. It doesn't exist if our limit is infinity, negative infinity, or does not exist. So in this case here, the left-hand limit is negative infinity. The right-hand limit is infinity, but the limit itself does not exist, right? As we approach 0, we're not increasing or decreasing without bounds. We're doing different things on either side as we come from the left and from the right. Right? And I'm going to end this podcast here. So a limit of f of x as x approaches a is called a limit at a point because x equals a corresponds to a point on a real number line. Right? So we're looking at what's happening at a single place. If x is approaching infinity or negative infinity, then we're looking at what's happening as our function increases or decreases without bounds. If it's x approaching a finite number, we're looking at what's happening as x gets closer and closer to a single point. Right? And so it is fine to use infinity and negative infinity, but remember those are non-existent limits because they're not finite numbers. In the last part of this lesson, we're going to look at piecewise functions. Bye for now.